to start this session by acknowledging the land on which we meet today and you are on. And I also want to start with introducing our presenter today. I'm facilitating Hafez Alavi, and our key presenter today is Mr. Ken Bia. So we thought that it is unconventional and great and creative for us not have an introduction and just have a quick chat for you to know Ken. So I have my first question to you, Ken, which is like generally the question I ask people when I like what they're doing. I say, why are you doing what you're doing?
Oh, great question. So been in transport engineering for a long time. And at the start of it, it was really, to me, just this big juxtaposition between the industry I was working in before and the absolute pushback on any chance of death or serious injury. And, production would stop. Nobody would do anything because there was a possible risk. But the risk out there on the road network, especially, it was just so high, and everybody was just sort of apathetic to it. And then, I just love using, like any typical engineer, I love using math, science, data to solve problems. And this is one of the world's great problems. And so I love doing it. And then I love the idea of just sort of making sure industry is up to speed on latest practice and the sound principles and sharing that information. So that's why I love running the training.
Beautiful. So Ken, I've got two more questions. My second question is about you have always been humble, self-aware, and really present in the moment that, I have views, but other people have views as well. Acknowledging that, what are your key strengths? 3 key areas that you find yourself like really good at or you're passionate about. What are those 3 key areas?
I think it's a good point, Mike. One of them is that there are some pretty strong views out there in road safety, and I think it's important that we don't dismiss them and we respect people's views, and they may differ to ours, and you've got to sort of be open and listen to them and respect them and have that conversation. So I think there's a bit of sort of negativeness out there between some camps. So that's one. I think just the openness to listen and talk to people and listen to their ideas. I think technical rigor is something that is important, and sometimes getting lost. I know we're all desperate to deliver, and people are jumping around jobs and wanting to progress really fast and quick. But there's some really wonderful technical knowledge associated with road infrastructure, and I think that needs to continue to be developed in young engineers. So I'm pretty passionate about that one, and then just safe system principles at their core. Like, I've always agreed with them. I fundamentally agree with them, and we've got a lot of work to continue to do to bring that into the wider industry. But we get passionate people like the group we got here who are already on it, and they just want to know a bit more about some applications. So I'm keen to get into that.
Yeah, that's fantastic. And Paul, yes, I'm interviewing Ken for a job, and he's already got the job. So my last question is, we have people here who are here in this training, and you mentioned something that really resonated with me, why you do training after doing hundreds of trainings. What excites you about training?
Yeah, well, there's only sort of one project I can be working on at a time. I mean, well, you can have multiple projects going, but you can only focus your attention on one of them, and so it sort of limits the reach of some of the principles that we've discovered really work and really save lives, prevent serious injuries. So, the idea to spread that nice and wide and get people as safe system champions with technical knowledge, and then they are teaching and mentoring others, and they're teaching and mentoring others, and the spread continues.
Yeah, totally. That's great. Ken, I stop here. I have more questions, but I stop here. So please send your question in the chat room or to us. I will be facilitating. Ken will be presenting, and at some sort of times I will stop and we ask questions and we go on. So please keep your question. Ken, floor is yours.
Thank you. And I see Zachary's already wanting to know about buses. So I'm on it. We'll talk about platforms. We'll talk about ramp grades, lengths, all of that. So it is coming up. Thanks, Zachary. And do keep your questions coming in. But I'm going to jump into it. And we're on the how. The how. So as I mentioned, I'm not going to be able to cover off all of your questions, everything you want to know. I will hopefully get into a few of them. But just the sheer amount of stuff to talk about in the time means that I'll cover it at one certain level. But, shoot me emails, connect with me on LinkedIn. We can chat further about any specifics you've got, and if I can't answer it, I'll point you at people who can. So I gave you a little preview of what we were going to be covering today at the end of Prue's session with this lovely picture of Warrnambool in the southwest of Victoria. Look at those beautiful raised crossings on the approach to the roundabout. Lovely town centre upgrade. And so we're going to be talking about lots of those elements. And ramp grades are in there, lines and signs. I'll probably spend most of the time on those ramp grades and sight lines. They're two things I think are really misunderstood, or that people just want to get some extra knowledge on. The positioning of roundabouts, raised crossings around roundabouts, is something we know the value of roundabouts at a wider road safety perspective. They do a wonderful job, and we've had some challenges with pedestrians and cyclists around roundabouts, but the addition of raised crossings around roundabouts is just a win all round. And so thinking about where we position them and some of the considerations. Lighting and drainage, I'll touch on them quite briefly, and pavement as well, fairly briefly, just to give a few key insights. We better get into it. So I think Hafez, Prue and Bridget have done a really good job sort of talking about design objectives at these different levels, from sort of strategic planning objectives all the way down to sort of general design objectives. And I'm drilling in a little bit further than that, but we want to locate the crossings on pedestrian desire lines so that, point where pedestrians are, where they generally want to be, that's the desire line. For pedestrians and cyclists, cyclists will go a little bit further off the desire line than a pedestrian will, but still we want to try to ensure that efficient, direct route. So we've got to really factor that into our consideration. We got to think about all road users. I think Bridget hammered this home so well that I don't need to really cover that further. High alignment with safe system principles, and that's thinking about human tolerance to physical force. It's thinking about mistake making. It's thinking about some redundancy in the system. Hafez Pro covered that quite nicely. And then this idea that we wanted to think at a network level and that connectivity, and Hafez's beautiful exercise, sort of walking through rather than just saying, well, we'll have one there and then we'll have one over there, and they're disconnected, thinking about that consistency along a corridor. So there's some overarching objectives. If we get into specific design principles, this is where things, I think, have changed over the last decade or so. And we very much traditionally just thought about the chance of a crash and stopping the chance of a crash happening. Now we're really also focusing on the severity of the incident. In fact, in my design principles there, I put it first. I put severity considerations first. So I talk to engineers and technical officers and the like, and I put it in this simple term. The human tolerance to physical force in a crash is a design parameter. The same way, like designing for a 1 in 100 flood level or a V3 lighting, right? Whatever metric that you say, no, we have to meet that. It's also, you have to meet the tolerance of the human body in the crashes you're expecting. Okay, so we have to reduce that severity to within tolerable limits. And that's a sort of core thinking of the safe system. Sure, we've got a long way to go to pull the whole network into that, alignment, but we should be thinking of that, especially as we build new facilities, right? But we don't ignore likelihood. No, not at all. Like, that is super important as well. We're going to do everything we can to lessen the likelihood of a crash with really good sight distances, appropriate sight distances, good signage. That is conspicuous, clear, concise, comprehensible, credible, consistent, and compliant. They're the 7 C's of signs for those who don't know them. Appropriate drainage, lighting, and then managing speeds again for vehicles, but sometimes potentially for pedestrians and cyclists on the approach to the conflict point. And that reduces the likelihood and also the severity of crashes in these incidents. So I'm going to delve into those design principles. Keep your questions coming in, of course, and Hafez, at any time, just jump in, because I just keep motoring on. So you're going to have to just jump in on me at any point. Right, let's start with one of those likelihood factors, and it's sight distance. And sight distances to pedestrian crossings has been the point of recent debate at an Austroads level. So lots of Australian and New Zealand discussion going on. There were some recent changes in the Austroads Guide to Road Design, which I officially complained about, and they're now going to change them. So they've agreed to change them because they took, I'll explain the approach as I go through it, but it's getting changed. But I'll explain both approaches to you, so you can have a think about how to I suppose, understand what sight distance requirements we've got. Now, you're all getting pretty good at the thumbs up or scary face on the Wombat. And here we go. We're up in Queensland, and we've got 2 carriageways. We're approaching a zebra crossing, so a pedestrian crossing. I'll call it a zebra crossing because that's the common name we use for it. And I just want you to either give thumbs up to that if you're happy with it, looks good to you, or thumbs down, or the scary face if you want. And we'll have a little bit of a chat about it. Oh, people are scared of this. Well, we did talk a little bit about this last session with Prue about multi-lane approaches to crossing points. Now, they're not allowed under the Australian standard. It says you cannot do this, but there are quite a few of them either existing out there, or people go, well, they say, well, what else can I do? Like, I'm stuck here. I want to provide pedestrian facilities. It's a major traffic route. What can I do? So let me just explain why that's an issue for anybody who's trying to sort of picture that. If you've got multiple lanes, I've done this with 3 lanes, like just to really sort of highlight it. But you can see there you've got pedestrians crossing, and that car sort of trailing behind. They have quite a big dynamic visual obstruction, masking, we call it. So there's a whole lot of that crossing that they can't see. And if that car here slams on the brakes because somebody's coming out, this car may continue through, and we've got that conflict. So that's the concern. What about this one? Okay, now we still have 2 carriageways, 2 lanes in each direction. This one's on the approach to a roundabout, but this could work mid-block. And you see here, so this is the other carriageway over here, and this is, we've got our 2 lanes approaching a pedestrian crossing again. Let's see what we're saying. Thumbs up or scary face, or type something in the chat if you want. Okay, so looks like we've got a lot more people happy with it, Hafez.
Yes, but you're creating some mixed views here, Mr. Ken. What is happening here?
Yeah, well, for anybody who's still saying not happy with it, pop into the chat what some of the key specifics, because there are, of course, always little tweaks that can be done. But overall, I'm much happier with this. I'm much happier with this because essentially we've taken that limitation, which is the dynamic visual obstruction, the sightline impediment of the other vehicle, and we've lessened it because we've provided a refuge island in the middle between the 2 lanes going forward. So if you look at that same crossing point, and you can see there a photo with a truck where how they're sort of out, there is quite good sight lines then for a pedestrian approaching from that side due to that buffered area. So if you are, and I've just picked one example, there's a few of these around Australia and New Zealand, but we did have some discussion like, how do you do pedestrian crossings on the approach to a multi-lane roundabout? This is how you can do it in a fairly safe manner. The other important thing about this is the raisedness of it, right? So as we bring those speeds down, the risk just lessens, the sight distance required lessens. So that is a way that it can be done. Okay, there's a little bit extra land required, a little bit of extra width required. But if you're at the point of saying, well, what can I do? This is a legitimate alternative. So you can see that if there wasn't that buffer, like the truck would be sort of there, and you can see how we've really reduced the sight line to any pedestrian crossing. And that's sort of a demonstration there where we've really opened up that ability for the vehicle coming through here to see that pedestrian who's crossing that way. Okay, so that was just the two-lane approach, which was the topic of a bit of discussion. I wanted to pop those in there so people had an idea. Of course, you can look to signalize a crossing. We talked about grade separation. You know, the provision of an internal splitter island in that sense is going to be way cheaper than grade separation, even with your land requirements. But sometimes, you know, you really need to provide that continuity of flow for vehicles because of primary traffic route and the crossing for pedestrians. But let's talk about sight distance and just some basic fundamental sight distance on the approach to a crossing. So up here, I've got different types of sight distance. I'm going to take you through these. Some of you are going to get this as a bit of a refresher on sight distance calculations. Some of you, this might be the first time. So I'll go through from a very basic perspective. But we're thinking about approach sight distance, crossing sight distance, and stopping sight distance. Or, you know, safe intersection sight distance is the same formula as stopping sight distance. So some people might say that, but stopping sight distance is more appropriate to say in this situation. So some key sort of parameters we talk about for a pedestrian crossing, a raised pedestrian crossing, or a not raised pedestrian crossing for that matter, a 1.6 meter setback. That's a point that's taken, and for the life of me, I can't tell you why it was picked exactly at 1.6. I will give a prize out to anybody who can tell me why 1.6 was chosen. I've always used it. It's in a lot of the design standards. The other ones are 1.2 meters a second as a walking speed for a pedestrian. That's a parameter we use. And then we use this height of 1.07. And I can tell you why that 1.07. That's the height of a person in a wheelchair, which is important consideration. Also, you know, it covers off kids as well. And that's a parameter we use. So a few parameters there, a few sight distances. So we better get into it. Ooh, as Zachary said, falling over distance, tripping so he wouldn't land on the road. I like that. Don't know if it's right, but I like it. I'm going to not jot that down. Okay. Here we go. Some people will simply say, I'm going to talk about parking as a sight distance impediment. Some people will simply say, well, I'll just follow whatever the road rules say or the road code. So the Australian road rules talk about a driver must not be stopped at pedestrian crossing an intersection of the road 20 meters before. And then the road code for New Zealand talks about 6 meters. Now, in some situations, this might be appropriate, but there's a lot of situations where it won't be appropriate. And it won't be appropriate in either direction, in the sense that sometimes this is way too conservative, and we may not be able to get a pedestrian crossing or a raised crossing in where we want it, because people say, well, we can't meet this sight distance requirement. So that's bad. In other situations, right, it might be not enough that we put that in, and somebody approaching will not have enough time to see, to react, and to stop if a pedestrian starts walking. So, okay, there's something to consider, but in both cases, it clearly says you can deviate from this using parking control signs. So we can just re-sign it out of that. Okay, let's start by talking about approach sight distance. Now, approach sight distance is the same, approach to an intersection, approach to a pedestrian crossing. It is the driver's ability to see what is coming up and take appropriate action. And we're going to do that to the road surface. Okay, that's what we're looking at. So the driver should be able to see the line marking on the surface of the point that they're looking at. And we take that from a 1.1 meter driver eye height there. And within that, you can see there that we've got reaction time, which we can use from the Austroads Guide to Road Design Part 3. We've got the operating speed. So that's the 85th percentile speed in kilometers per hour of the vehicle. We've got a coefficient of friction or deceleration, which you make a judgment call on. And we're thinking in there the grade, are we coming on a steep downhill or an uphill? That's gonna change things and factor things out. So the idea here is that a driver approaching a pedestrian crossing should be able to see it, the fact that it's there in time to make in time to react and judge and come to a stop if necessary. Now, you might be thinking, well, that's pretty obvious, but if it's going around a curve or something like that, that becomes interesting in ensuring we can meet those sight distance requirements. So putting a pedestrian crossing around a sweeping curve is something that we need to consider how we go about doing that. Not to say you can't do it, just how do we go about doing that? But if we use we'll use a straight road to talk about another sight distance requirement. And this is what Austroads is currently requiring of a pedestrian crossing. And I'll explain why I don't think this is right. I mean, it's fine. It's actually more conservative. You're going to get bigger sight distances, but I don't think it's appropriate. But we use this thing called crossing sight distance, CSD. Now, crossing sight distance essentially says we got our pedestrian here, and they're going to need to get from this point to this point, right? So the distance becomes important, okay? And we need to ensure that they've got enough sight distance to see this vehicle and judge that it's going to stop and that they've got enough time to get across the whole width of the road. If you've got a refuge island, that they've got enough time to get to the refuge point. So you can see there that the CSD, the crossing sight distance, talks about a critical gap in seconds, which is the length and the speed of travel of the pedestrian, which we talked about, 1.2 meters a second. They give a 3-second buffer in there now. And we talk then about the approach speed of the vehicle. Okay. So what you do then is say, okay, that has to be kept clear of anything that will block sight lines to a pedestrian. And we're going to need to know, okay, we've got the 1.6 setback, we've got, say, 3.5 meter lanes, could be something different. So then you're just going to sort of calculate this through. So CSD, and you go 3.5, 3.5, 1, 1.2, add the 3, which is that 3-second extra buffer, and you get 141 meters. Okay, so that's the distance here that we need to then create that sightline triangle. Okay, I'll come back to that. Oh, Hafez has got the hand up. Right.
So Ken, like whenever we have a question, I don't interrupt. I just raise my hand, and whenever you're comfortable, you can get to our questions.
Thank
we
you.
have a question from Farhana that says, if there's a curb outstand at race crossing, can we reduce the restriction on parking distance on approach sides?
That is an excellent question. Let's put a pin in that, and I'll come back to it, because we're just establishing how you calculate these, and then we'll talk about, what if we can't meet them? What if we can't meet them? How do we still ensure that we can get these crossings in place?
One question also, why do we need to calculate the whole distance? Isn't the purpose getting the pedestrian away from the trajectory of that vehicle? So if they reach to the second, direction, aren't they safe? So why do you use the whole distance?
Yeah, no, it's a fair point. So yeah, we would actually be doing a second sight line off this end. I should have probably clarified that better, and you'll do it both that side and that side, if that makes sense. So yeah, no, well clarified. Thank you. Okay, so if we raise the they cross in both directions. Yeah, so somebody sort of said that. If we raise the crossing, this becomes interesting, then, doesn't it? Because what do we use as the 85th percentile speed? Right, so we had this 50 km/h, 85th percentile speed of free flow, but we know that they're not going to go over this crossing at 50 km/h, are they? But their slowing down happens at a certain sort of point along this road. So if there's no pedestrian there, for example, they're still going to slow, aren't they, to go over this? It acts like a local area traffic management device. It's a speed hump. Okay, so we need to now start thinking and factoring that into our consideration. So at some point, they're going to slow down regardless of whether there's pedestrian or not. And say that we've designed the ramp grade, which I'll talk about, how we make this consideration later, to, let's say, a 25 km/h ramp grade speed. They should get down to that speed. And so one theory would be that you could just simply take a 25 km/h 85th percentile speed and use that for your calculations. And then you could calculate that out at about 71 meters. So obviously my diagrams are exaggerating everything just for visual effect. Okay. But the reality of it is that, and I'll show this in a future slide, that a vehicle sort of slows at a point and then makes a decision at a decision point. Okay. The reason that this use of crossing sight distance is not appropriate for pedestrian crossings, and why I lodged my complaint and has been accepted and changes happening, is because the time it takes for the pedestrian to cross that road is irrelevant, right? The key thing is for that driver to see the pedestrian approaching, right? And then have, good amount of time to slow and to stop. Then it does not matter how slow they walk and how far they have to walk, because that driver waits until they're past and it's safe, right? So while crossing sight distance provides bigger sight distance triangles, and that's great at an individual site, and you go, great, okay, well, what's the harm of being able to see the pedestrian further back? Like, that's got to be good. That's got to be safer. The bigger the sight lines, the safer it is. Well, that's sort of true at an individual site. But what we find in practice is that a whole lot of local governments especially are saying, well, we can't meet this crossing, so we can't put a raised crossing in. We can't put pedestrian priority in, right? And that is going to be a massive disadvantage for us in safety and active travel and transport. So I'm saying we don't need to go to these massively conservative things. If you can, great, do it, go nuts, right? But the reality is that car parking's always in there. It's hard to, remove things. And we want to have more and more of these crossings going out there. And we shouldn't have that as an impediment. So what we will be using is stopping sight distance. Now, stopping sight distance doesn't factor in at all the distance to travel across and the time it takes for the pedestrian to cross. It's just literally reaction and braking. Like, can the driver see the pedestrian, right? And do they have enough time to brake and stop? Okay, Hafez, before I jump into this, let's have a question.
So 2 questions. So if you are you that in that one, so why ramp grade speed is asked by Serene. Why you have used that your ramp grade speed?
Yeah. I'll explain why I've used ramp grade speed using this slide in a second.
And also, just to confirm, Farhana is asking, is that 71 meter the summation of the side lengths of the triangle?
No, that's the distance. That's the distance from the vehicle, front of the vehicle, to the crossing point. It's actually the point of conflict there. Yeah. That's that distance. Yep. Okay, so here's what actually happens when you've got a raised crossing, okay? So the driver, assuming that they're coming in at an 85th percentile operating speed of 50 kilometers an hour, right? They see the crossing, right? At the point that they can see the crossing, right? They're preparing themselves to slow down because of the raised nature of it, not because they can see a pedestrian, right? They've got to navigate over something that's raised. So they start their braking process, right? And then they'll get down to a speed, right, that they are comfortable going over the raised crossing. And that's what I'm calling the ramp grade speed, right? So that's what we'll put as the advisory speed on the raised crossing sign, right? And that's associated with how steep the grade of the ramp is, right? So they will get down to that speed. They'll have their foot on their brake, right? And then there's that specific point where they will say, oh, there's a pedestrian there, I'm going to stop. Or there's not. They go through over the ramp and then they accelerate. So we then need to think about, okay, well, where, like, do we take the 25 or do we take the 50 as our choice on operating speed? And the answer is that they're sort of your bookends of what you need. I mean, you can go higher than 50 if you want, but 25 is sort of getting to your absolute limit. So you're able to pull things down, sight distances down and down and down, but you can't go lesser than that 25 or ramp grade speed. And there's significant differences in the sight triangles. So they sort of bookend what you would be thinking about in terms of sightline triangles. Now, things that are blocking those sightline triangles, we see trees, shrubs, we see different controller boxes and all sorts of bus shelters and bits and pieces. But the big one we see, as has been already pointed out, are park vehicles. Now, if you ever get into some obscure clause of something that says that a parked vehicle is not a sightline impediment because it's not always there, don't just stop. Like that's ridiculous commentary. Somebody's found something buried away somewhere, but that's just absolutely not right. Of course, it's a sightline impediment. I'm going to jump past that one. So we had a wonderful idea immediately of what we could do there if we can't meet these sightlines because of parking or the like, and that would be some sort of curb out stand or curb build out, depending which side of the ditch you're on, is what you would call it. But you can see immediately there that 1.6 setback then has been pulled forward, and so our parking can really press up quite close to this because we've pulled the pedestrians out at a point where they're more visible and easier to see. So that's a great little solution for where you can't quite meet these. And the shop owners are jumping up and down about the idea of parking removal. And you've actually narrowed down the crossing distance. Not that with a raised crossing and priority, crossing distance becomes far less and less important in terms of safety, but it's nice to narrow it down. Vehicles will also slow a little bit because of the narrowing of that, of the road. So that's one option. If you can't meet that, I suppose, has anybody got any other ideas if we can't meet that? If we can't meet that, as I sort of overlay the other sort of sightline impediment. I mean, these are just mock-ups. So when you actually get out there and pace it out and work it out, it's a bit different. Anybody got any other ideas? So Peter's asking a question about shared path facilities. That's coming next. And okay, so Zachary's gone lower the speed limit. Good, that's an option. And it might bring down the 85th percentile speed on the approach. Okay, some things to try to enhance the visibility of the crossing itself, signing it, different signage, refuge island potentially. So these are all things that you could possibly think about in the design, but really we can look to slow this vehicle down on the approach, like further back, just really through speed calming, speed humps, speed cushions. So we give them almost double slowing down if you really are stuck. Yeah, so you could think about reducing that 1.6 requirement, bringing it back to less. We see this sort of interesting play out in pedestrian crossings at roundabouts, because you're taking a sharp sort of turn. Often you'll have buildings built up right up to the blocking sight lines there to a pedestrian crossing point if you set it back like that. But an important thing to remember on this is you're talking about 85th percentile speeds. You're not talking about free flow speeds back here of approaching vehicles or speed limit. So the mechanics of a vehicle going into a roundabout is that they slow down significantly. So, that's one thing. The second is that if you can't meet crossing sight distance or stopping sight distances, if you can meet approach sight distance, so that's the vehicle being able to see that there's a crossing there, the vehicle will actually take action to ensure that they can see if somebody's crossing, as long as that's really a well-positioned and well-highlighted raised crossing. Most of the time, when you actually use an operating speed of somebody navigating a left turn at that roundabout or a right turn at that roundabout, you discover that the sight triangle is actually really pretty low. And, if you are doing that, raised crossings on all approaches actually reinforce that lowering of speed at that point. So our sightline triangles open up significantly because we've enforced that speed lower. If somebody was, wanting to take fast sweeping left turns around this roundabout, well, we've slowed them with traffic calming on the approach to that, and we're ensuring the sight lines and sight triangles open up. Okay. I'll let people ponder this little thumbs up, thumbs down, and check in with Hafez. Lots of comments. I like it. People are excited.
Two comments, Ken, maybe that you want to comment on. One is changing the type of asphalt by changing the friction. And also, is there a safety difference between raised crossing on each leg compared to raising the whole roundabout?
Yeah. Great question. So absolutely agree with whoever said friction, because that's one of the key parameters for stopping sight distance, which we can then use. So that's a really good point. Thank you for that. And is there any difference in raising the whole intersection or raising the particular crossing point? So the only difference is that you will get a slight acceleration through the full raised area, but For most urban roundabouts, it's just inconsequential. It's really small. So you're going to get the same outcome, basically raising the whole roundabout and the approaches as compared to just isolated crossing points. But if it's a big roundabout, then you might get that reacceleration up, and you want to factor that in. There's practical considerations with that as well, and I'm sort of going off a little tangent. When you raise a whole roundabout, right, you often end up pulling the roadway to the curb height, and you get tracking of vehicles over onto the nature strip, onto areas where pedestrians might be, because there's not that distinct difference there. So that's one practical consideration. So you can use sort of mini bollards, bell bollards, and these sort of things if you're going to do that. The second one is your drainage and how how you're going to do that. Sometimes it actually works a whole lot better by raising the whole lot. But consider that it's going to cost more to raise the whole thing as well in most situations. But they're just very sort of practical design considerations that you need to work through. So I saw lots of people not too pleased with this, Hafez, and I think that's fair enough. So we talked about crossing points at bus stops and the importance of it in some previous sessions, because we know we're going to have people getting off the bus and they're going to want to cross because their house is over there, or when they want to get on the bus in the morning or whatever, they're going to have to cross the road. So it's an absolute going to be a crossing point for sure. So having a crossing is a good thing, but thinking about, okay, well, the bus is blocking sight lines here, absolutely. And we don't have really speed calming or anything to slow vehicles down to lessen the sightline requirements or lessen the severity of any incidents that occur. So even though that bus is only there sometimes, it's still a sightline impediment, and it's something that we really wouldn't want to, we wouldn't want in that position. Continuing on the thumbs up, thumbs down, or thumbs up, scary face. What about this one? Okay, haven't switched the lights on yet. I was out there with a colleague doing a post-opening road safety audit. So ignore the not in use signs. They'll be lit up at some point. But yeah, most people seem pretty happy with this. We were really quite impressed with it. Out there on Yarra Boulevard in the Richmond area. It has nice, it just has nice characteristics. It's got a nice ramp grade. It's well lit. It's got good lighting, signage on the approach. It's got the curb out stands, curb build out, so you can see a pedestrian nicely. Everything really does polish up nicely. I mean, there's always little improvements you can do, and I'll point out some of those later. But overall, I mean, this facility is just going to be top-notch in protecting pedestrians crossing at this location. And Paul's already, eagle-eyed Paul has seen something there he's not too happy with, which is some leaf litter and the like. Is that what you're going to point out, Hafez?
No, yes and no. So it's really great to have Paul here with really practical comments and observations. Maintenance will be discussed. One question for you. So, Ken, thinking systemically, we have a surge in the usage of technology, also vehicle safety features. At some point, it would be great if you make comments about how we can combine features like AEBs, or, for example, when you're talking about bus stop, how we can use road safety technology to give information to cars instead of infrastructure. So maybe that systemic thing at Somerset would be great if you could comment on.
Yeah, it's a whole emerging area, and we're having a lot of fun as road safety auditors and infrastructure designers in trying to think about how we leverage new technology in our road designs and operations and things that we can do to really enhance what's coming. I mean, the principles of a well-designed well-designed raised crossings are going to be winners with new technology or old technology. And as we transition, we're going to see wins all around. So if we can get those right, it's better. But it is really relevant when we're starting to say, well, we can't do that for one reason or another. And then are there other ways we can still get the same outcome we want utilizing the technology? I will, maybe touch on that a little bit more as we tick on if I've got a bit more time. So yeah, I as I was saying, this one really good. Some of those specific things, as Paul's pointed out, we'll have a little chat about, but generally pretty wonderful. Interestingly, though, I'd come back for the nighttime inspection with my colleague there, and we just sort of witnessed people parking right up close to the refuge island. Which, if I go back a slide, you can see there's signage to prevent that. However, that area has sort of been left as an option. Now, the curb outstand and the raised nature of this crossing makes it not the biggest risk out there, but I didn't like it. So there is possibility that you could do some building out back. It makes it a little bit interesting for people to park, do their reverse park in and out, but just factor it in as a consideration. That people may still park there if it's a especially busy area. And we can, have a chat about enforcement of these sort of things to supplement that. Now, this one's a little bit, you haven't got a lot of vision of what's going on and the like. However, we can do a little thumbs up, thumbs down on it. I'm not too, well, you probably want a bit more context when you want to see what it's like on the approach and through. I'll maybe move through it. It actually is pretty good. I think, again, the ability to park right up to here comes into play, but the curb build out is really good. So the outstand is good. It's raised nicely. It's got a lot of good features to it as well. But one interesting thing, and the reason I sort of bring this up is I'm just going to clear my little lines there. That spot there is so attractive to a landscape architect. They just get super excited. Okay, they want to put sculptures in there. They want to put, the big welcome to this town signage and all sorts of things, because it's such a prominent, nice spot. Or they want to put beautiful rose shrubbery and all of that. Now, we just need to remember that that's within the sight line, and we want to think about that height, that we don't want any impediments, and rule of thumb there is sort of 500 to 1.5. Keep that clear. And ensure the sight lines are there. Now, why don't I use that 1.07 that I talked about for a wheelchair eye height? Well, if you took the 1.07, then somebody in a wheelchair approaching that, all you'd see is just the little top of their head motoring along. And so that's not what we want. You actually do that from... The reason we talked about 1.07 is the ability for them to see under a crossing sight distance requirement. But 0.5 to 1.5 is industry practice on what you need to make sure you keep clear. So low ground cover, fine, right? And then maybe if there's a tree canopy sitting over the top, but not using that as your display of welcome to town or big sculptures. Wear tall hats. I really like this one in Warrnambool as well. Now, somebody's pointed something out to me on this, which I'll let others make call. The reason I like this is it's a great crossing. It's on the approach roundabout. Everything's looking good. Grumbling in the Warrnambool community about, oh, it's so slow to drive through the town centre these days. Yeah, okay. Well, it's really nice to walk through the town centre now, so that's a bonus. But anyway, this little buffered area is good, just because we have vehicles back out of angled parking, and if you put a parking spot right up to that, they'll back onto the crossing. It's not the biggest issue ever. You know, it's not the biggest road safety issue ever. It's just not great practice. So if you can, you know, provide that buffer area there, it works really quite nicely. The thing that somebody pointed out to me, though, is that you should have a buffer area next to a disabled parking on the driver's side, which I was like, oh, yeah, that's a good point. But I like it from one perspective. In that buffered area, we shouldn't have anybody backing onto the crossing as they reverse out of their angle parking. Now, I am going to give these people a little break at some point, Hafez, but I want to start the sight distance for shared path crossings or cycleways for that matter. Like if you've got a cycleway and you want to give it priority or a shared path, yeah, we're going to have some different thinking, aren't we? Because, well, we've got a slightly different eye height because a 1.4 is about what you use for a cyclist. But what speed do we need to think about of the cyclist coming in? Because that's going to influence the sight distance, isn't it? So there's some really interesting research on speeds of cyclists at different grades and flat and males, females, average pace. So I've put a reference in there if you're interested in some of the details on that. The TMR guidance out of Queensland talks about 15 to 25 kilometers per hour as rider sort of travel speed. Around that 20 is generally seen as shared path bike speed. Like that's commonly taken. Cycleway, 25 to 30, like Victoria would use 30 kilometers per hour if it's just a dedicated cycleway. And which is moving along pretty briskly on a bike, but certainly achievable. So we're going to factor that into our thinking as we calculate sight lines for these shared path crossings. So we popped some figures in there. Now, if you have those separated facilities like this, so you're providing that priority for cyclists in their own dedicated crossing and pedestrians, so not like a shared path, but you're sort of separating them out like this, you're going to do sightline calculations on your faster vehicle, which is going to be the bike one. You're going to try and ensure you're creating that sightline for bikes crossing there. If it's a shared path, you're still thinking about the bikes as well. So that's becoming a bit of common practice around Australia where you do this, and New Zealand actually as well. New Zealand's doing a fair bit of this. So we do need to think about that sight line for the cycleway itself. Hafez.
So Ken, usually in your practice, you're very cognizant of differences between jurisdictions and Australia and New Zealand. We have a comment here from Manish that any particular reason why tactiles are grey or silver? It's yellow for peds and green for cyclists in New Zealand. And I think it's about 2 or 3 slides before. That one. No. Oh, this one.
Sorry.
Yes, this one.
Yeah, okay. The tactile ground surface indicators, we are not specific on color, but they should contrast the pavement. So they're not contrasting enough there, which is, yeah, something that should be probably rectified. But yeah, I don't know why we don't have a specific uniformity in the color of those. In terms of the color of pavement, green for cyclists, yellow for shared path facilities, red for busways, is pretty sure that's consistent across Australia and New Zealand. Somebody can correct me if I'm wrong on that. Okay, so here's a little video approaching on a bike, approaching a shared path priority crossing, and I'm going to play it again. But so what we're looking at there is, can we see that car? There it is. It popped out. Has it got enough time to see us coming and make a decision to stop or not? I'll play it again. So here we are running along. What's the site triangle? Can they see us? Can we see them? Have we all got enough time to make our decisions? Yes. Okay. So how do we work that out? How do we work out what those site triangles are? And again, it all comes back to that stopping sight distance. But the thing is, we want to, in this situation, create that site triangle that means that a driver has time to see approaching cyclists and make that decision. But we also want to ensure that cyclists have time to see that vehicle. And if that vehicle is going to overshoot, that we have time to take some evasive action. So I think the Victorian government's done the best guidance on this. So I'm going to follow their process through. You could do it from a first principles perspective. That's not an issue, but they've sort of streamlined the process for us in this design principles for raised priority crossings. And we'll pop that into the learning management system so you can have a look at, you can have a read of that as we go. But the sight distance requirements, based on safe intersection sight distance or stopping sight distance, we talk about sort of these travel times. And that's about different scenarios. So is it a high-speed environment? Is it a low-speed environment or very constrained environment? So I'll come back to this in a second. But here's the theory, right? So vehicle comes in, bike comes in, they couldn't see each other, they're both traveling along, and we've got the crash. So we don't have the appropriate time to see, to avoid, to react. Now, hopefully that would be slower because of the raised nature of it, but the bike's going to be coming in at speed as well, so we've got some challenges. So you open up sight lines to some point, and we're going to call distance back from the conflict point for the cyclist, A, and for the driver, C. Okay, I will use a B later, but so the idea then is if we cleared and opened up that sight triangle, the driver should stop because they saw the cyclist coming and let them go. But also, if we come up here and that cyclist identified, hang on, I saw that car coming, it's not slowing down enough, they should have enough time to make that emergency braking maneuver. Okay, so we often run a shared path facility or a cycleway alongside a major road. It's a beautiful spot to do it because you've usually got a bit of land. It's a nice, corridor. And especially when we're upgrading roads these days, people are more and more considering the need, providing facilities for active transport, which is wonderful. So we've got this corridor. But we've got to think then about, well, how do we create this appropriate sight distance for these crossing points, which is where all the side roads come into the main road. And so this is where I'm going to use B. And the B is the distance from that point of the vehicle back to the turn point. So we want to create all of these sight lines, and I'm going to call it like a sight envelope. We want to keep that free of hazards because you can see all of those different points of requirement of different turns and different directions that bikes could be coming from. So we use a curb return of 20. Now, that works generally pretty well. If it was a massive sweeping curve, you might need to adjust that, but generally that works quite well. I'm just going to finish off this sight lines on, and then we'll take our little break and we'll check in on any questions. But let me just show you how to actually calculate these. So we talked about that one. So that sight triangle where it's at a 90 degrees. There would also be one which would be like a scenario 3, we'll call it, where the path is going to make its turn at some point and you create the crossing there. That comes up a bit as well. So we do think about it. You just measure your distance A in that curve of the path as well. So to actually calculate these differences, A, B, and C, we decide on what is the what's the scenario. Is it a high-speed road? Is it a low constrained environment? And you pick that and you decide on one of those. So select a travel time. Then we work out A based on, is this like a high speed cycleway? 30 kilometers an hour we're going to take as a speed. Is it a fairly straight generic shared path facility? We'll go down to 20. All right. Are there maybe some chicanes on the approach, or the riders are going slower? We might go down to 15. So you get a bit of decision on that. And then you've got your selection on your travel time based on the scenario you got from over here, right? And then you find your distance back for the cyclist. You do that same for B using these other tables. And as I say, you could calculate this from first principles yourself using stopping sight distance calculations if you want. These tables are just there to make your life easier. And C, again, we take based on the operating speed of the approach and our scenario travel time. And there's a few assumptions in there, flat, 2.5 meter deceleration. So, in this scenario, if we select a 3-second travel time, we've got A at 17 back, we've got C at 21 back. That then creates your sightline triangle, and we should be trying to keep that free of fixed hazards, well, fixed sightline impediments, as I should say. Couple more slides on sight distance. There's specific jurisdictional nuances. The TMR guidance there, the supplement to the Australia's Guide to Road Design Part 6A, Walking and Cycling, talks about some setbacks of 4 meters on path arms, which is relevant in some situations. And like, what do we do if we can't provide that? We've calculated the site and we just can't provide it. Like, we go, no, there's a building in the way, or there's a tree there, a big shrub or tree that is like super important, and we're never going to cut that down. Before you go to abandoning the idea of priority crossings, like, we've got things that we can think about. So we can implement speed management for the cars to reduce the speed on the approach, speed humps or other means to slow that vehicle on the approach. You could also reduce the speed of the cyclists on the approach, and you can do that with raised platforms for cyclists, chicanes, or others. You might decide to go and start to select lower travel times in those scenarios. And then you're into the point of saying, well, maybe we need to actually reconsider and provide a signalized crossing point or some other features. So here's sort of raised features on the approach to address some of the sightline challenges. This was also because of some drainage issues, but you can see, you slowed the vehicle back here before it's getting there, and slowed on the approach to the crossing point. So that's pretty good. And, this one was an interesting one. Even though it's quite low, they did go to a stop sign because of some sightline challenges. That, to me, is sort of the lowest on the effectiveness of control, but an interesting one to consider. Okay, we'll give them a little bit of a break, Hafez, or do you want questions now, or?
Just one comment, one question. So I know that you will be talking about at some stage about the color of some of these, crossings, and so one question about that, I'll leave that to you to answer when the time is right. Mm-hmm. Also, Paul here ask you a question. Maybe I paraphrase the question. What is the highest speed environment that you have seen or you have done a priority crossing on?
60 km/h speed limit. So we did reduce the speed limit from 70 to 60 in one. And then, yeah, you really want to calm it down and make sure you're doing that. But yeah, we've certainly done raised facilities on higher speed roads. So raised intersections, raised approaches to roundabouts and things like that on 80 km/h roads. And you need to, be very gentle with your grades early, and then sort of give people a low ramp grade and then a sharper one a little bit later, sort of slowly bring their speed down. But yeah, it's an important consideration.
Also, just one other comment. So we talked about speed management for cyclists as a measure of if you cannot provide the visibility. Can you mention a number of those speed management options for cyclists?
Yeah, so you can do you can just do a raised platform on a cycleway. That's done. I've got some pictures of it I can dig out of how you would do that. So that will slow cyclists. You can do a bit of a chicane, and I also link that in with providing setback for vehicles, which I'll show later. That'll wash off a little bit of speed that a cyclist approaches, that they need to make a chicane sort of turn around to get across the road. You can do some sort of taped rumble strips on the approach, which does a little bit, not a huge amount. So there are a few options.
And also, there is an observation here, and I really agree with the observation, that sometimes our guides are not consistent with practice. For example, people observe here that in some of your tables, you have 80 km/h, and we don't usually do such treatments on 80. They're very rare. What are your thoughts on having those figures in the tables?
So I'll show you the situation where you would use 80. I'm just going to go back to it. This. So the reason you use it 80 is that if this was a massive arterial running at 80, okay, this might be a side road at 50 or something like that, right? But you need to factor in the speed of a vehicle approaching here at 80. And yes, it's great to have a shared path facility or a cycleway next to an 80 km/h road, because we do not want to put like a cycle lane on that. That's just not going to be aligned with safe system principles. So that's the reason for having 80 in that table.
So with that, can we ready for a break? Is it 5 minutes break?
Yeah, let's have 4 minutes.
4 minutes. So I'm timing 4 minutes. We'll stop recording, come back in 4 minutes. Enjoy your coffee. Thanks again.
Thank you. And yes, you can go back and watch the recording also if you want to see it again as I jumped through. So that'll be uploaded to the learning management system shortly. Okay, let's get back into it. Roundabouts. So we talked about roundabouts and the advantages, and then how wonderful it is with a raised crossing around roundabouts, especially in those town centres where we've put those roundabouts in the past to address some issues. And we've really got two options here. One is the raised crossing right on the essentially footpath line, or set back sort of that 4 to 8 meters. I've got 5 to 8, 4 to 8 is usually okay. If you go beyond that, I mean, you can go beyond that, but you just start to be really taking a pedestrian off their desire line. If they are walking here and you make them have to walk way up here to cross, to come back and to continue on their journey. So that's why we're sort of trying to limit that a little bit. But in these two scenarios, you can see there's some advantages in vehicles propped to wait for a pedestrian to cross can be out of the circulating carriageway, so other vehicles can continue their journey there. in option 2. In option 1, as they wait, we'll clog up the roundabout. Now, part of me says, who cares? Like, I don't really mind if it's clogged up, because this is obviously such a high pedestrian activity area that vehicles, that we're prioritizing pedestrians, and that's that. And it's actually not, but that's, sometimes the situation is all varied and different. But actually the safety issue is more about the vehicle exiting. And so the vehicle entering the roundabout, not exiting, if we've provided this buffer space, they have that area to prop, that they're not propped on the crossing waiting to make their decision. But if it is right up there, you can see how they have to prop right on that, on the crossing as they wait. Depending on, sight distances, they may prop back there. But that just then means pedestrians sort of have to walk around. It's not, again, the biggest safety issue we've got out there, but it's something for consideration. But that's why we would say preferred for this. If you can do it, it's preferred. But it's not like that must be done. You can certainly do option 1 if that's what you've got to play with. So here's an example of that option 2 that we talked about, where you can see that the vehicle can approach, a pedestrian can be crossing, then they can sort of roll over the raised crossing, prop in there, waiting to enter the roundabout. And here's the sort of second one, where we've got the crossings right on the essentially up at the hold line of the roundabout, and vehicles waiting, and the vehicles won't be able to really navigate through. So they're both legitimate options. My concern more is about that vehicle entering the roundabout, sort of propping on the crossing as they wait to enter the roundabout, and pedestrians walking around it, which is something for consideration. The angle of approach. So pretty much anything we raise on the road network, we want to try to ensure that it is perpendicular to the path of travel. The reason for this is predominantly around heavy vehicle stability as they navigate over it. You don't want them to have one wheel hit first and then it wobbles the whole vehicle. Motorcyclists consideration as well. In terms of motorcyclists have a bit of lean as they navigate around, and we don't like to provide any vertical deflection while they're having that lean. So really want to create that perpendicular setup if we possibly can. So here's the design of a raised signalized crossing, actually, in New Zealand. Raised signalized crossing. It's not been, this is just the design. But you can see it's sort of right on that sweeping bend. We've got a bus lane there. We'll have heavy vehicles and motorcyclists through here. So one point there was, well, we can't do anything raised at this location. And then there was, pushback. No, we want to slow vehicles. This is a crossing point. It's quite well used. We should be calming this down. Any ideas maybe from the group on how you could still achieve this slowing of vehicles at this crossing point, but not have as much of the instability issues that arise with this particular setup as it is there?
Ken put some hints in his preamble, so maybe you can use some of the hints.
Maybe I've stumped everybody, have I?
No, but I think you've given enough information to create ideas. So, Ken, do you want to repeat your preamble a bit?
Yeah, well, we want to ensure that we've got perpendicular path of travel for vehicles, or as perpendicular as we can, when they hit the raised part.
So you have a couple of, yeah.
Good. I think we've seen, yes, people are They were just sipping away at their coffee, I think. Okay, so we've seen lots of good ideas there. Everything from putting humps on the approach where it's straight to slow vehicles down, to splaying or the like, so altering the raised section, putting 2 humps and the like. So those are certainly options. They went with the splay there, so sort of spreading it out and angling it so it's more perpendicular, which is good. Or, you know, you could be extending them out, utilizing splitter islands in the middle. Or I do like the idea, if you're really struggling, to just put the speed calming on the approach and then know that the crossing, they will be going at lower speeds. So there's actually been quite an abundance of guidance around pedestrian facilities at roundabouts. And I've pointed a few of them in there. What I often, while I do in this course, is sort of point you at different things. I plonk them into the learning management system so you can, you don't have to go searching for them. But yeah, I'm not going to go through every jurisdictional nuance of how this is done and what they're asking for. So here's a cycleway where you can see that sort of chicane I talked about, which will slow the cyclists a little bit on the approach to the crossing point. And so that might be one way you can get a little bit of speed down for cyclists if you need. But it also nicely does this bent out cycle lane facility. So a vehicle that is turning in from one way or another just has that area to prop out of the stream of the traffic on the through road here. So it sort of sits nicely there, and we like that bent out. It also really helps with the driver that's making the turn in for their decision making, that they don't have to make a harsh decision, I suppose, quickly as they make their quick turn in past a vehicle. Okay, so let's talk about ramp grades. And here, Hafez and I are out having a look at some ramp grades. Do cyclists and peds have priority there? Oh, yeah. So this is a cycleway priority, and it's trying to provide, well, it's a bit hard to see here. There's a giveaway. So it is providing that priority for this. And then you get up to here, and then you've got to wait for priority there as well. It's a bit of an odd setup. Okay, ramp grades. Here we go. Lock in, because we're going ramp grading. Okay, like the basic theory on it is the sharper the ramp grade, the slower vehicles are going to go to navigate over it. Now, how do they know what it is? Well, we provide them with some advice on what they should do, so that helps. But they'll go over it once, and they'll get a good feel for what they can do. And then the next time they go over it, they're going to adjust accordingly, okay? So we know that the bulk of drivers are repeat users of a road. And so if we design something with a very shallow ramp grade like this, but we sign it like this one, right? Yeah, the first time they go over it, they might go 20. And then the next time they'll go 30 or 40, and then they'll go, no, this is about a 50. And that's what I can go over it at. And they'll just continue to do that. So the ramp grade's good, and there is a bit of information about it. So you can see, I'm going to show you lots of different sort of ramp grades. The 3.6 with this is a like stock standard raised crossing, 1.2, 3.6, and 100 mil high. I'll use that, and then I'll start to adjust it for different scenarios. So who knows the ramp grade of this? It's 100 mil high and it's 1.2 meter long ramp grade. Who knows what that is? What's the ramp grade there? Now we do grades in like 1 in this, not a percentage. For some reason, I don't know why we ended up doing that, but we do 1 in and thank you. 1 in 12. Somebody's on it. Yeah, good. Now they're all coming through. 1 in 12. That's right. So it goes up 1 to 12 long. So 100 to 1,200. So it's 1 in 12 is the ramp grade of that. Now, when you're thinking about ramp grade, you're thinking about from that, what is the angle essentially? So if you're on a slope down or a slope up, your ramp grade will change. There's something just to factor into your thinking. But then we understand from some great research and lots of people running lots of vehicles over ramp grades at different speeds and having accelerometers and understanding what are we expecting to see out of this, that we will get vehicles within that some speed reduction range. Okay, that's where they will find themselves. So these different colored lines show ramp grades. And we can then say, all right, 1 in 12 was what we had there. We are going to get around that low 20s as the speed vehicles will be going through there. Okay, so then we can sign that a 25 or a 20 if we want. If we flatten it out a bit down to a 1 in 16, well, then we would be thinking something around the 30, a little bit over 30 might be the speed that vehicles will travel through there. And you can then, get an understanding of what our expectations are based on this. Now, the graph there sort of goes up to a certain point. If you want to go higher speed scenarios, we've got some further information there, which comes out of a Victorian government document, race safety platforms, and yeah, you can get some information there. Now, to save you the time of sort of digging through your local jurisdictional guidance, I've collected the different information that your jurisdiction will talk about. I started with Austroads information there. There's lots of info in there, then some Australian standard stuff, some specifics on TMR. I mean, TMR, like this is quite amazing, 150 mil high, and I'll explain why that is later. And then we've got the Waka Kotahi NZTA information there as well. Okay, so let's have a think about this. We've talked about a 100 mil high ramp or platform, which is pretty standard height that you would be doing this. And we've got that 1.2 length. So that's a very standard one. But for different reasons, you may want to alter this. And I'm talking now just from a principles perspective. I know each jurisdiction likes to do their own little nuances, but we'll go with the general principles of this because we can design to general principles, even if it doesn't meet up your local jurisdiction in some situations. Okay, you could lengthen your ramp there, which would flatten it out a bit and make it a little bit easier for some vehicles to get over it. You could make it higher if you're in environments you really want it to stand out and you may be linking with higher curb height, or you really want to enhance that. And if you have short ramps and very high, it's going to be very steep, very slow to navigate over that. And we might have some troubles with some lower vehicles. You might go out there. Then like down at a 50 or a 75, we're seeing a lower ramp and it'll be shallower. So there's the sort of theory on how you can adjust things. But the thing we've got to consider is that a vehicle is going to approach this. And we have challenges in a number of situations. The vehicle can bottom out approaching it, as in the nose of the vehicle hits it. We can have vehicles get stuck on ramps or bottom out as they go over the ramp. They can have the back of the vehicle scrape as they've gone up onto it. And then, of course, the back can scrape as it comes down. So, these are all things we need to then factor in to our choice on ramp height, ramp grade, and the like. And just one more, and then I'll go to Hafez. There is the possibility of nosing out, but if you nose out, you've probably nosed into the ramp, depending on how it's been done. Okay.
So Ken, question, and I'm trying to fully understand this. This is about accommodating changing in-grade crossfall. So I would say, excuse me, it's just about crossfalls and how we address them in the design.
Yeah, so I sort of alluded to that at the start, where you've got to factor that in. It gets quite complex. I do later on have a slide that sort of shows how you can adjust things. It really does sort of need to be done in CAD to work out what your grades are, and then your vehicle will be able to get over it. But this diagram here around what the different ground clearances are for vehicles is addressing Chris's point. So the ground clearance, the minimum ground clearance for vehicles, yes, is 100, but the length of between axles becomes then important on that, because you can see the 1 in 15 gradient minimum requirement or there for larger vehicles. And of course, buses are then something that becomes very, very interesting and very relevant. So lowered vehicles and buses are going to be our real areas of consideration. So let me talk about buses. Here we go. So the general minimums of buses across most jurisdictions, we're talking about the greater of 100 mil at that, or 6% between axle, okay? And that's going to be the same off the back there as well from the axle. So as we sort of factor that parameter in, as that's your low bus, commercial buses, so that'll likely be a coach or something like that. The commercial buses will have a bit more clearance usually. And so here's some sort of 12.5 buses, and it's got better angles, 14 meter, and they've done a 260 clearance. But again, that's a longer wheelbase. So we're seeing that the angles are becoming important. And of course, we've got articulated buses as well to consider, and they've got their specific nuances. But just to keep it in more simple principle terms, your low coach style bus, it will just bottom out on a 150 mil high before it even gets onto it. It's gonna hit it. The vehicle will sort of go up onto the ramp there, and then there's potential for it to just get stuck on a high ramp, and then drag itself through. But certainly, you can get the specifics of buses if you're in Australia on the National Heavy Vehicle Regulator website. That'll give you a lot of intel, and you want to know your buses that are going to be using the route that you're interested in. We do generally design for the ensuring that a coach can get over it. So this one, for example, it's not a bus route. Like, it's not getting the day-to-day or every hour there's a bus, or every 10 minutes there's a bus, right? But it is still the fact that a coach will come, it goes to the school, picks up kids, once a week. So we've got to make sure we can accommodate that. But with this 100 high, 1 in 15 ramp grade, the buses are fine. And this is a low bus. This is sort of the lowest you're going to find. So that can navigate over it. Sure, it goes over it slow, but it is absolutely navigatable. So if anybody's saying to you, we can't put that because the coach has to come in here, as long as you're going that 100 mil high and then the 1 in 15, it is traversable, or the vehicle's not meeting, like vehicle codes. where we get to more constant bus routes, okay, we do tend to drop the height down a little bit, 75, and flatten it out a little bit. And this is where we're starting to make little bits of trade-offs, because we know vehicles will go through, like cars will go through this a little bit faster, right? We are going to get good benefit. It's the crossing's raised, it's clear, and the like. But we've lost a little bit of what we wanted from that. But in order to accommodate the bus in a more friendly manner, that they don't have to go really slow through that. But a 1 in 20 or 75, that is really great for buses. It's generally really pretty good for pedestrians. That's to me a very good setup. You could extend your whole platform length to cover off the whole wheelbase of the bus if you wanted. That's an option that some people like, because it sort of lessens the up and down on the bus. Yeah, it's a big wide thing then. So this one was an interesting one where they went with the 75, but they kept elongating the ramp out, and it became a 1 in 27 ramp grade. Now, that to me is, you've gone too far. That will just be driven by a passenger vehicles at 55, 60. Like there's almost no point in raising that. Like, so that's just too far. And that was trying to be over accommodating of buses. This is a bus route. So, you're playing around with those sort of things. I think those ones that I showed, that 1 in 20, 75 on a bus route is really appropriate. If you're like just absolutely stuck and they're like, no, we can't do it, whatever happens, like, don't abandon the idea of slowing vehicles on the approach to a crossing point. This, I think, is a legitimate option if we need to speed cushions. The bus will straddle it. So the bus, can't complain. And we slow vehicles on the approach to the crossing point. It's not quite as good as a raised crossing. It's not quite as good because, for a couple of reasons. One is we don't elevate the crossing point for the pedestrians, so we lose a bit of value there. Second is you need to actually do it twice, because you need to do it on both approaches. And we always would do both sides of the road like this, because if you don't, vehicles we find just go around it. And that sometimes causes some other challenges. But you can also do this where drainage just goes like, we can't do it. It's too expensive to do all the drainage works. So here you can see a number of these examples. These ones done with spike down cushions. This one's done an attempt to put some sort of split island there to stop vehicles going around it. I'm not sure how successful that will be. If you're going to do that, probably you need to extend that a little bit further. And I'll do this one and then take questions. So there is the option to do asphalting of these. Some people talk about the maintenance challenges associated with spike down cushions. Some councils I've talked to, they're like, no, these things are great. They last a long time and they're really good. So it'd be interesting to hear your thoughts on that. But there is the ability to do this or concrete them in. And I'll leave this. Well, so the specs on it, sorry, Hafez, the specs on it there, you're trying to make that wheelbase wide enough for the bus to be able to straddle it, yet a passenger vehicle not straddle it. And here's a pretty cool one, using this sort of treatment on the approach to a signalised crossing point in Western Australia, probably 15 years ago, I think, is ages ago, and it was great. That's Bill Bowie there, taking a photo, if you remember Bill. All right, Hafez, question.
I miss Bill. And so, Ken, one comment, we have very sometimes important routes for buses that we need to cater for buses. And then you mentioned that, we can have a combination of treatments. So have a lower sort of a raised platform that caters buses and pedestrians, but also have humps on the approaches for cars so you can bring down. So that I really resonated with that comment. Just two comments here. One is about a design vehicle. And you talked about buses. Do we have a requirement specifically for what design vehicle we need to consider? And I would add heavy vehicles as well. So buses, heavy vehicles, what is the vehicle design required to consider?
Yeah, well, that'll be case dependent on your site. I mean, that's sort of the start of the design process, is to consider your design vehicle and then your checking vehicle, and make those choices accordingly. On some roads, you will be using a design vehicle, maybe of an 8.8 meter service vehicle, but your checking vehicle would be your bus, your semi or the like. And that's to just ensure that, yes, that vehicle can navigate over the raised crossing. It's not going to get stuck and the like, but it's not going to get used day by day by that vehicle.
And that points nicely to the sometimes confusion in the movement and place planning for our system. So some of these observations points that maybe the planning for this part of road wasn't really matching the need. A question quick for you, Ken. What is the longevity of some of these rubber cushions? Do you have any comments on that?
Yeah, so some councils that have installed them are saying that they get like 10 years out of them, and they're very happy with it. I think it's going to depend on the amount of traffic that that's going over them. As I showed, that if that's a concern to you, I mean, you can sometimes start with these, make sure everybody's happy and comfortable with it, and then you can put a more permanent concrete or asphalted solution in, unspike those, move them to a new location, try them out there. So
sorry, Ken, to interrupt. Obviously, I didn't get Zach's question. So Zach has a very specific question about table 8.8, and he's asking, will it be required?
I'm not sure. Did I show table 8.8? I might have to come back to that. I'm not sure what he's exactly referring to.
So Zach, we will come back to you on that question. Apologies, I didn't get your question.
Okay, I better keep going because, as always, I'm going to run out of time. So we've generally been talking about a ramp in and a ramp out of the same grade, but you don't need to do that. You don't need to do that. So here is an example of where the grade out, so the exit is much shallower, and that can be helpful for some of your some vehicles. This is one in New Zealand, and I think it's been done really well. But a key design element to this is that island. It's got to be a separated road, essentially, at least on the approach to this, because if you have two different grades, we are just concerned that a vehicle may come in here if there wasn't any separation, and then have two different levels and be destabilized as they navigate. So they've drifted out of their lane and they hit that or something like that. So somebody was asking about ramp grades and how we on different vertical grades, like it becomes a little bit challenging to work through. Here's a sort of live case study. You can see it's a downhill and they're approaching the raised crossing, and you're factoring in a whole lot of things into this because we can't make our shared path too much of an angle, right? Because as people try and navigate it, then they're walking on a big lean and their wheelchair will slip over and the like. Plus, we've got to make sure we're getting that actual speed reduction out of it. So, just to sort of accentuate that, or articulate it with a diagram, over exaggerated diagram, you see, if it's just to create a flat ramp like that, the bus is going to get stuck on it, or your larger vehicle will get stuck on it like that. So you can start to readjust and flatten things out, but you're trying to make sure that your path is not overly accentuated there. So as you play around with it, you can create facilities by elongating and the like that help. Now, bearing in mind though that the vehicles coming down here are getting less and less incentive to slow down. And you got to think about the vehicles going the other way. So in this one, for example, it was sort of a small, it essentially just goes into a bit of flatness and then levels it out coming in it's a really long accentuated grade back in. There's more cost associated with it, but it does provide that facility. Again, in some cases, you may just be stuck and you may just go speed cushion and say, speed cushion there. And you say, well, we don't actually need a speed cushion because the ability to turn in at speed and that's all we could possibly do. And there's the speed cushion, sorry. That example where you're not able to do that. Okay, ticking along pretty well here, and we do need a couple of minutes at the end just to jump into the learning management system and show people how we're going to finish. Lighting. So lighting is an important requirement at crossing points, and there's good information in the Australian New Zealand standard, so 1158. The lighting of pedestrian crossings. And what they talk about is essentially the vertical and horizontal planes that you need to light. So they do that. It's sort of like it's actually partly because, or it may actually, it's predominantly to light up a pedestrian's face as they are crossing for more of a personal safety thing. We want to ensure that a vehicle can see the crossing, but that's part of the consideration. So I'm not going to go through like how to do a full lighting assessment, but I just wanted you to be aware of that lighting requirement. They're the planes that we're thinking about that you would want to ensure you've got light at. So at the road surface, you're trying to ensure at these different locations, and at a point up at 1.5 is where you're trying to ensure we've got the correct lights, and that's that one of the face that we're really trying to ensure. So you just do a lighting assessment on it, and that will give you an indication. Now, the lighting can be a real impediment to people putting these in, the cost of it, but I really encourage you to look into the solar lighting options. I mean, City of Greater Geelong have just done wonderful stuff. They're putting solar lighting in at these, and it's very reliable, consistent, a lot cheaper, and the time is much quicker because you don't have to wait on all of those connection challenges. So something to really to look into. So that's one thing. There are challenges with light spill over into properties, and that one's a bit of a case by case. For those shared path crossings, you're thinking about that sight line and that's kind of where you'd want to start and ensure you've got your lighting. So the point that the vehicle can see the cyclist. So that's the critical point to be lit, right? You don't need to light the vehicle because they're going to have headlights on, and the cyclist will be able to see them coming at that location. So drainage, another big one that causes a lot of headaches with raised crossings, and in order to keep us moving along, I've sort of separated this out into 5 options, and one that we occasionally see, which is not really an option. That's to sort of keep the curb and channel running and just start your raised crossing out from it. Well, that's not going to be step free, as Bridget would talk about, and going to be a challenge for some road users. But we've got these sort of options. Okay, lower ramp height so you can get your flow over it. Positioning at the high point, well, that's great, if it's on pedestrian desire lines or very close to. Curb ramp down and up, or box draining, or pit and pipe. And so go put the water down and through. So let's just have a quick look at those. Pit and pipes is where we'd love to be going. It's expensive sometimes, but certainly gives us the ability there to keep that ramp clear, and you may need to increase the capacity there of that. So here they've put in some extra pits. So that's one option. Expensive. Then the idea of some sort of box drain or something where you keep the channel there and you put a plate over the top of it, essentially, so the water will flow underneath. And we had somebody rightly sort of point out earlier about the leaf litter and clutter associated with this and the potential on that. And it's certainly something to be aware of. I do like this facility just due to its lower cost. And, I see a few of them out there, but it was certainly something of note on that audit that we were out there doing, where it was only open or was only there for a couple of weeks. It was already clogged. So that's not a great outcome. Something we need to factor in there. So some different setups and some here utilizing the facility with this entry spot and into a little swale area, which is nice. And I have seen some places use that as a bit of a water sensitive urban design area where they can use that area I talked about as the landscape architect's dream spot, where you can then add some features in and around that. When we go with, just keeping it clear like this, ramping down and ramping back up, we're considering mobility scooters and the like. Are they going to get stuck on this? Are we going too sharp down and too sharp up? These ones are good, and they work quite well if you've got a fairly flat area, because you can, come in fairly flat and ramp it up, and you've got a bit of space to play with. I like this. I like this a lot. It's cheap. It gets us what we want, and it's really can be utilized really easily and well if you've got the space and the specifics there. So you can see a few of them here that I'm, again, fairly happy with. And I think they've done really well. Where you do have that higher drop down and up, I think we start to get into some problems there. And that one people may get stuck on. And that's where we might be looking at some sort of plate over this. And here's an example again of that sort of lip and the step-free nature of it. And there was I just watched this lady sort of very slowly taking her time to navigate over this. Okay, like part of me says that this is this is bad, but part of me says this is still good. Like, we're slowing vehicles. If it's clear, they will slow down, they'll stop. And it's a hell of a lot cheaper than trying to, put pits in and get water through. So I'm a bit torn on this. But Hafez.
I really love when you are quite practical, because we have limited time and budget. So it's very good for be practical. So one question from Farhana: what are the issues that we need to consider when designing a raised crossing on a slip lane in an urban environment which have heavy vehicles and high speed sometimes?
Well, you just need to think about the grades and try and find that appropriate grade. I think some of those examples I showed in the 75 ramp height is good. Certainly don't be dissuaded by that. I mean, if you've got pedestrians and cyclists crossing at that point, we want to slow vehicles down. That's it. So yeah, just playing with your ramp grades and heights, I think. I'm going to just show you the last couple of things at Fairs. I know there's a couple of questions there, and I think apologize. Signs and lines, really, we go to 1742.10. It's well described how to sign a raised crossing in Australia. It's there. It's fairly clear. We give a warning of the raised nature of it and the regulatory crossing point. Yeah, a couple of explanations of that. We do that, advanced warning of the raised nature of it. I want to combine them. I keep putting this out there and just saying we've got too much sign clutter on the approach to these. Can we combine a few? They're not accepted. New Zealand stuff, you can see slightly different. Use the triangles on the approach, and then there's the diamond on the approach as an optional feature if you want that extra additional warning. And you can see the setups here for the pedestrian and cyclist priority across and the different bits and pieces. So you can get that from the Waka Kotahi website and get all the details and information there. And some information here on the signs from Queensland, which is associated with essentially creating this as a road. So you have giveaway signs, and then you have the shared path as a road, and we use that, give way and then 2 pedestrian and cyclists underneath as supplementary. So in the notes, you can see there the information about signs and lines, but also, when you might use flashing lights or not, tactile ground surface indicators and raised reflective pavement markers in there as well, and shared use crossing. So I really just popped all that in because I knew I wouldn't get time to go through it all. So I've pointed you at the specific notes for that. We want to contrast the color of the crossing. So red's not recommended for the not enough contrast from visually impaired people. So the black on the white is what we're really looking for. And finally, pavement. So you've got really options there of asphalt or concrete. You want to do a bit of a dig out here and to ensure that it lips in if you're doing that with asphalt. And if you do it with concrete, it'll last longer. It's more expensive though, and you sort of need to do it. It takes more time but it's much easier to get a nice wedge in that. You might need to do a little bit of potential pavement strengthening around the approach, as somebody mentioned. I haven't seen and done too much of that or know too much about that. You could think about some speed calming on the approach to lessen that a little bit. And that's probably the point I wanted to get to. And I'm going to stop sharing, just bring up the learning management system to show people how to finish. While Hafez, you tell me if there's any final urgent things that need to be covered.
No, nothing. And I'll just thank you for your putting energy and just getting us to the end. That was a feat. Thank you.
Yeah. Okay. Oh gosh, sorry. So in the learning management system, I've gone to the wrong profile. Sorry. In the learning management system, right at the end, you just need to fill up a feedback form. And that will then, actually, no, I'm in there now. Where did you go? Sorry. What have I got, a minute? I'm racing the clock here, Fez, but I'll do it. Thank you, Fez, while this comes up. You've done an excellent job as usual. Are you seeing the learning management system?
We do.
Yeah, right. So right down the bottom, up. Okay. Now, I'm giving you a little quiz for this course. So you're going to get in there, multiple choice quiz, just a few little questions to get you going. Then, once you've completed that, feedback form, and your certificate will release once you've filled the feedback form out. Do the quiz. I'm sure you won't find it too hard. Consolidates your thinking, feedback form, and get your certificate. Feel free to post your certificate online, tag in Hafez and myself, and we'll
Bridge.
Give you a thumbs up. But thank you. Get in contact. The copy of the slides your slides are in the module here. There you go. There are the slides. And you'll be able to see that. And you can see here on the recording appears maybe 24 hours later. So there's all Hafez's bits of info. And you've got the resources I talked about here, lots of different things. Road design and engineering resources folder, lots of stuff in there. Keep in contact, ask any questions, shoot me an email. Thank you. Sorry, I rushed a little bit at the end.
No, thank you very much, Ken. And thank you, everyone. We really enjoyed your participation, your questions, some of your difficult questions, which made us thinking. We really appreciate you also. If you spread the word, we want to spread these solutions on the network for pedestrians, for children, for the elderly. So pass on the word. Thank you, Ken. Thank you, everyone. Have a lovely day.
Bye.
Bye.